In this video, I will show you how to test hypothesis for difference of two population proportion using Ztest. As we have discussed in my earlier video for testing of hypothesis about the population proportion, whereas in some cases we are interested to test the hypothesis about difference of two population proportion. Earlier I had discussed about population proportion, but now we are interested in difference of testing of difference of two population proportion. In some cases it is applicable. For example, one may be interested to test whether the proportion of alcohol drinkers in two cities are same, or one may wish to test proportion of literates in a group of people is greater than the proportion of literates in the other group of people, etc. When you want to test population proportion for two different population proportion, we require the test for testing of hypothesis about the difference of two population proportion. Such a cases I will address in this video today. Then let us have a problem for this. In this problem we have encountered with two cities. In this problem, in two cities we have taken consumers of wheat. Then let us see a problem. In a random sample of 100 persons from town A, 60 are found to be high consumers of wheat. From town A, 60%, which means from the sample 60 are found to be high consumer of wheat out of 100 sample from the town A. In another sample of 80% from town B, 40 are found to be high consumers of wheat. So in town B, 40 are high consumer of wheat out of 80 samples selected. Now the question is, do these data reveal significant difference between the proportion of high wheat consumers in town A and B? From the data of town A and town B, they are asking us, do these data reveal a significant difference between proportion of high wheat consumers? So we want to test this and later we have to take a decision out of it. We want to test a hypothesis at 5% level of significance. Then let us encounter it a step-by-step approach. Firstly, I will define success and failure of this problem so that it will be easy to understand. Here the attribute under study is high consumer of wheat. Here high consumer of wheat. We have question regarding high consumer of wheat only. And we define our success and failure as getting a person of high consumer of wheat and not high consumer of wheat respectively. So we will define success as high consumer of wheat, failure as non-high consumer of wheat. So then we are given that town A considered as N1. So from N1, which means town A, total number of person in that sample of town A is 100. Here in a random sample of 100, we are having sample of 100 in a town A. And in town B, we are having 80 sample from town B. Look at this, in another sample of 80% from town B. So N2 is considered as sample of town B. So total number of person in the sample town B is 80. Now we want to define success. As I said, success will be taken as consumer of high consumer of wheat. X1 is a high consumer of wheat from town A. In the town A, out of 100 samples, 60 are found to be high consumer of wheat. So X1 equal to number of person of high consumer of wheat in town A is equal to 60. And let us see town B. So here out of 80 sample, 40 are found to be high consumer of wheat. So number of high consumer of wheat in town B is 40. Now we can calculate the proportion of this high consumer of wheat from two towns. So the sample proportion of high wheat consumer in town A would be P1 small p, P1 equals to X1 by N1. I am taking a data of town A. So P1 success proportion of town A, X1 is a high consumer of wheat is 60 by N1 number of sample from town A. So our proportion would be X1 is 60, N1 is 100 and proportion is 0.60. Now we want to look into the sample proportion of high consumer of wheat in town B also. So in the town B we have to consider X2 and N2. So P2 is a success of high consumer of wheat from town B. So X2 in town B is 40 and N2 is 80. So our proportion would be 0.50. So once we define our success and failure, we can go for formulation of null and alternative hypothesis. The same old problem I have copied here to make you difference. Here we want to test the proportion of high consumers of wheat in two towns. Say P1 and P2 is not same. So you can look into the problem. Do these data reveal a significant difference between the proportions of high wheat consumers in town A and B? So that we want to test the proportion of high consumer of wheat in in two towns, that P1 and P2. So our claim would be P1 not equal to P2. Since we want to test the proportion of town A and B are not equal, so our claim would be, population claim would be P1 not equal to P2. Since claim is P1 not equal to P2, its complement would be P1 equal to P2. Since here the complement contains the equality sign, so we can take complement as null hypothesis and claim as alternative hypothesis. So our null and alternative hypothesis would be H naught is P1 equal to P2, that is a proportion. We have taken equality sign from complement, whereas our claim is P1 not equal to P2. We should be very careful with the claim because we will test the claim at the end. So our null hypothesis would be P1 equal to P2. It means proportion of high wheat consumers in town A and B are same. So our alternate hypothesis would be opposite to this, P1 not equal to P2, which means proportion of high wheat consumers in town A and B are not same. One more thing we should consider in the hypothesis, since alternative hypothesis is a two-tiered, which means alternative hypothesis contains equality sign, we can take which means it is a two-tiered test, which is not a one-tiered test, since alternative hypothesis is a two-tiered, which is a two-tiered test. So now we can go for testing normality condition in proportion. Unless you test the normality condition, we cannot move further. So we will test the normality condition in this. As I told you in my earlier video, there are two cases will arise in population proportion. But since we are dealing with two population proportion, it would be somewhat different. But basic concept is same for normality test. So as we know, the case one would be when sample sizes are not sufficiently large, that is any of the condition like N1 P1. Earlier we dealt with NP because we had only one population. Here we have two population. So N1 P1 must be greater than 5, or N1 Q1 must be greater than 5, or N2 P2 greater than 5, or N2 Q2, this is Q2, N2 Q2 greater than 5. Does not mean which means any of the condition like N1 P1, N1 Q1, N2 P2, N2 Q2 are not greater than 5, which means we have to deal this under the binomial test. So then what we have, second case in the normality condition is the same thing when the sample sizes are sufficiently large. Here in this case, when the sample sizes are not sufficiently large, when these N1 P1, N1 Q1 are not greater than 5. When all these N1 P1, N1 Q1 and N2 P2 and N2 Q2 are greater than 5, then by central limit theorem, the sampling distribution of the proportion P1 and P2 are approximately normally distributed, so that we can go for testing a null hypothesis under Ztest. Now let us check the normality condition of this problem. This is a condition which I explained just now. Now let us check the normality condition in this problem. As I said we have two population 1 and population 2. From population 1, as you know, the number of sample is 100, and population proportion, which means high consumer of wheat, are 60% out of 100% selected 100%. So N1 would be 100 and P1 would be, which is a small p, P1 would be 0.60. So if you multiply 100 into 0.60, it would be 60. 60 is a greater than 5. So N1 P1 met a normality condition. Let us look into the another shade of this. N1 Q1. So from the same population 1, N1 is 100, as we know. If you want Q, we have to minus 1 by 1 from P. Our P value is 0.60. 0.60 is 0.4. So Q n1 q1 would be 100 into 0.4 equals to 40, which is also greater than 5. Then let us see N2 P2 also. In the population 2, our proportion is 0.50. Just we calculated that. Out of 80 sample, 40 are high consumer of wheat. 40% are high consumer of wheat. So 40 by 80. So which would be 0.50 is a proportion from the population 2. So 60 is a proportion from population 1. 50 is a proportion from population 2. So from population 2, number of sample size is 80 and the population proportion is 0.50. 80 into 0.50 which would be 50. 50 is also greater than 5. So N2 Q2 also we can take 80, number of sample size is 80 and proportion remaining proportion from 1 minus P would be Q 0.50, same thing. So 80 into 0.50 50, which is also greater than 5. What we are seeing is all these N1 P1, N1 Q1, N2 P2 and N2 Q2, all the four things are greater than 5. So which means sample size is sufficiently large in the sense. So since sample size is sufficiently large, we see that a condition of normality meets. So we can go for Ztest. So here on the right side you can see, since this is a population proportion of two population proportion, we have to estimate a combined proportion of high wheat consumer in two towns. So formula to calculate a combined proportion is this. So that's a p hat. In this side we can see that a p hat. So p hat equals to n1 p1 plus n2 p2 divided by n1 plus p1. So n1 is sample size, as we know, 100 from population 1 and p1 is 0.60. 100 into 0.60 it would be sample of x1. We know that we found that x1 is 60. 100 into here 100 into 0.60 is a 60 and plus n2 p2. So 80 into 0.5 it is also x2. So 80 into 0.5 would be 0.4. So sample size from population 1 is 400. Sample size from population 2 is 80. So you can take this formula or else you can take this formula directly. Both are same in the sense. So here n1 p1 would be 60, n2 p2 would be 40, or else x1 would be 60, x2 would be 40, and n1 is 100. We can see here n1 and p1 n2 is 80. N2 is 80. So if you add these together, 100 by 180, 100 can be 25 100 and 29 180. So p hat would be, which means combined proportion would be 5 by 9. Now we want to calculate q hat. As you know, if you subtract p hat by 1, so 1 by p hat, you will get q hat. So we will subtract 1 by p hat. Our p hat is 5 by 9. 1 minus 5 by 9 would be, the remaining things would be q hat. So 4 by 9 is a q hat. So one thing is clear in combined, while you are estimating population proportion, you will estimate the p hat and q hat. So now we have two values, one is p hat, one more is q hat. For finding combined to estimate combined proportion, we will use this formula, and now we found p hat and q hat value. Now we can move further. Now we can directly go for testing a hypothesis using Ztest. So to test Ztest, the formula we use to calculate is this: Z is equal to p1 minus small p, p1 minus p2 divided by square root of p hat and q hat, just we found just now, and within the bracket 1 by n1 plus 1 by n2. So this is a population proportion, just we found earlier, and p1 and p2 small p, and combined population proportion, that's a p hat and q hat, and that would be multiplied by 1 by n1 plus 1 by n2. Also we have all the data I listed here, that is a p hat and q hat, small p1, small p2, n1, n2 and alpha. We have these data. Now we will apply this data to the formula. So after applying to the formula, we will calculate the problem. So the details given here I have applied to the formula. That's for small p1 we have a proportion of population proportion from population 1 is 0.60. I have added here. For population proportion 2 0.50 I have replaced with the formula, and within the square root p hat, the value of p hat is 5 by 9. We have replaced that I have, and q hat that 4 by 9 I have also replaced that pq, and within the bracket 1 by n1, the n sample size from population 1 is 100, so 1 by n1 100, and plus 1 by n2, where n2 is 80, population sample size from population 2 is 80. So I have replaced here all the given details in the formula. By moving further, I will simplify this formula. 0.60 minus 0.50, I will get 0.10. So if I multiply this 5 into 4, that is 20, and 9 into 9 81, and I will divide 1 by 100 and 1 by 8, and ultimately I will add these two value, so that I got 0.0225. So in the next step I will simplify for still more. So 0.10 remains same, and divide 20 by 81 and later multiply from 0.0225. I will get 0.2469 within the square root. I will still more simplify this. 0.10 remains same. If I take on the square root of this values, that as 0.2469, I will get 0.0745. Ultimately my tested statistics under population proportion for two population proportion is Z is equal to 1.34. So by this way, after replacing formula to the given information, we have found test statistics. Here one thing is very clear. While you are calculating with the two population proportion, one thing is clear, you want to find out the population proportion firstly, and after finding population proportion you want to find combined population proportion, that is a p hat and q hat. Once you found population proportion and combined population proportion, the remaining data you will have with your problem only, that's n1 and n2 you will have. So you can replace all the details given in the problem, and you found proportion and combined population proportion. So I have replaced that, and ultimately I found that tested statistics for two population proportion is 1.34. So now we are having tested statistics. Now we want to compare this tested statistics with critical value so that we can take a decision. So which means at 5% level of significance, we have to see the critical value for Z score, and we know that this two-tailed test, since alternative hypothesis are two-tailed, so this is a two-tailed test. For two-tailed test, we have to look into the Z score for at 5% alpha. Here it is our critical values for Z test. We know that our level of significance is 5%. This is a 5%, and also we know that we are dealing with two-tailed test because our alternative hypothesis having a two-tailed test. So our critical reason for this problem is 1.96. So now we can plot this critical values to the graph so that we can take a decision by comparing with tested statistics. So here I have plotted all the data which is given by, that is a tested value, and critical reason also I have plotted to this graph. So we know that our tested value is 1.34. That's a positive, which would be fall in the right side of the region, which means our tested statistics is falling in this red corner, in this red shaded area, which is falling our tested statistics. Whereas our critical value is a blue shaded, will end up at the blue shaded area. Here nearby at 2, our critical value will fall. That's our critical value is 1.96. In the left side also minus 1.96, it will fall here. So you can see that clearly that it is not falling in the rejection region at 5% alpha, 5% level of significance. It is not falling. So which means we can take a decision out of it since it is not falling in the rejection reason. The critical values for two-tailed test at 5% level of significance are, we know that we obtained that critical values that plus or minus 1.96. And look at here, so moving further, since calculated values of tested statistics Z is 1.34 is less than the critical value of positive 1.96 in the right side of the region, and also greater than the critical value of minus 1.96 in the left side of the graph. So which means, what does it mean? Which is falling in the non-rejection region. Look at here, non-rejection, which is falling in the non-rejection region. So we do not reject the null hypothesis. It is very clear, we are not going to reject the null hypothesis. We will reject the alternative hypothesis, which means our claim is alternative hypothesis in this case, which is a special case. Our claim is alternative hypothesis, but we tested null hypothesis. We tested the complement, that's a null hypothesis. We will fail to reject the null hypothesis, which means we do not reject the null hypothesis. We will reject the alternative hypothesis. So this is a way how we will calculate population for two population proportion under Ztest. Thank you so much for watching. Please do subscribe to my Vision Academy YouTube channel for further videos on statistics.